All right. So now we're going to go to the next section. And the next section really is just doing some problems. We're going to do like the next four sections are going to do something that you already know how to do. I hope. Maybe you don't know and you'll learn this time. So um, let's see here. All right. So the second section is when we're going to make a claim about the population mean. And we're just going to assume that the population standard deviation is known. I told you before that's not really the case when you do research, but just for learning purposes, we use that. And it made more sense when we talked about the confidence interval. But let me just do a little repeat here. The central limit theorem, right? It talks about the sampling distribution. Everything we do is based on the sampling distribution, which, do you remember what that is? That is a distribution that is constructed by taking many, many samples of the same size from a population. And then basically you calculate the statistic from each one of those samples and you come up with a distribution. It's a sampling distribution. You're probably tired of me saying that, but that's what this is based off of. So this is not the distribution of the population, it's of the sample, right? And that from the central limit theorem we know is centered on the population mean, all right? So this number, like this is the center of the sampling distribution, and this is the mean that's calculated from all the population data. And these two values are equal even though you get them in a different way. But we're just gonna, calculate, concentrate on the population mean here. And we know that the standard deviation of the sampling distribution of sample means is equal to the population standard deviation divided by the square root of the sample size. All right, and this we know. So this is what we're doing in this section here. And I guess just to review what we did in the previous section, we had an H0 and an HA, and this was the mean. I think we had greater than or equal to 13, and then the mean down here, the alternative hypothesis was less than 13. And then we're going to assume the H0, right? The H0. And we'll say the mean is 13. And then our rejection region is down here. We're just going to say, let's make it a significance, level of significance of 0.05. That means that area is 0.05. You know, other common ones are 0.01. Sometimes they're really small down here. And then we're going to get a test statistic. Now that test statistic could land anywhere, right? So these are just calculations from the sample. And I guess just so this is the scenario that we're going to do in 7.2. This statistic is a mean, and we're going to assume that sigma is known. All right, we're going to do this test. Now, typically when these tests are done, you don't use the x values, right? The data point values. You use the standardized values. So this translates, right, to the standard normal, where the mean is equal to 0. And the critical values then, like the critical value down here, all right, this is z critical, and this is the standardized, I hope you can see that, standardized test statistic. It's the same thing, but you just map these onto the standard normal curve. And so your numbers, instead of being 13, this is going to be 0. And instead of being 10, this will be like a -1, depending on the standard deviation. Okay? But you've seen that. I just wanted to kind of show you that so it'll make sense when we look at some of these problems. let me see if I can do this. Bring this over. And let's see if that works. All right, so hopefully you can see this. All right, so we're just going to do a few problems here in your homework set. This one says, this is number 3. Find the p-value for a left-tailed hypothesis test with a test statistic of z is equal to minus 1.83. Can't read this. I gotta turn this light off. Decide whether to reject H0 if the level of significance alpha is 0.10. All right, so let's work on that. Remember what the p-value is, right? It's the area that comes from the region created by the test statistic, all right? So let's, here's how you do this. Let's go StatCrunch. Let's see if this will work. This is what you do at home, right? You try to do your homework and you get blocked out and I'm not getting anywhere either. Okay, so let's work on this problem 3. Again, sorry about that. Let's see here. Find the p-value for a left-tailed hypothesis test with a test statistic of z equals minus 1.42. And then decide to reject H0 or not. All right, the alpha is equal to 0.10. All right, so how are we going to do that? Remember, the p-value is the area that's created in the tail by the test statistic. And the test statistic is a standardized one here, it's z. So we're going to do that with this calculator, normal. All right, and minus, so it's a left-tailed test, right? So we've got the arrow in the right direction, and the test statistic is minus 1.42. All right, so let's grab that there. So this is where the test statistic is, all right? And this is the area that's created by that test statistic. Now, these are standardized, but the areas are the same. All right, so we're going to put that in there. What does it say? Round to 4. Okay. Nice work. All right, now, is the p-value, is that smaller than alpha? It's 0.07. Yes, it's smaller. That means we can reject. The p-value is smaller than alpha here. Reject H0. Nice. Okay, good. All right, let's go to the next one here. Oh, find the p-value for right. We know how to do that one. Let's do the next one. All right, here's the one. Here's where you find the critical value. The critical value. All right, the critical value is the value that corresponds to an area specified by alpha. In this case, it's 0.05, and this is left-tailed again. All right, so there could be more critical values, like if this is not a left-tailed test, if it's a two-tailed test, there would be a critical value on each side of the graph. But let's do this one. I wonder if my StatCrunch is up. Okay, let's do it. It's left-tailed again, the alpha. So it's the area this time is 0.05, right? The critical value is the value that creates an area of 0.05. And we've got this. All right. Copy this, put this in here. What does it say? 2 decimal places. All right. All right, good. And that is a left-tailed test. All right, so this is two-tailed. That's way off. There's a right-tailed with alpha there, and this is what we want here. The alpha is to the left of minus 1.64. Okay, good job. All right, so the rest of these are hypothesis tests, and we're going to do number 8. Let's see how this goes. Nutritionist claims that Tunica, that's not number the one. Oh, I think it's number 9 I wanted. Yeah, I want to do this fast food one. All right, fast food restaurant estimates that the mean sodium content in one of its baked sandwiches is no more than 922. No more. That means 922 is the max, right? Is no more than that. So that's the upper limit. So everything else, so that means less than or equal to 922. And that is this one right here. There's the equal sign. All right, and the claim is, in fact, the H0 here. Random okay, so let's just check that first. All right, the next one is, all right, so now we're going to do, actually, the critical value. We can do that in 2 different ways. Let's see if I got my, all right, is this a left-tailed? Okay, so what kind of tailed? This is a right-tailed. This one's right-tailed, right? Because the alternative is greater than. And we want to find the critical value. Where's the alpha? For an alpha of 0.05. So here we go. 0.05. And this time it's on the right side. Oops, let's do that again. 0.05. All right, so there's our critical region, our rejection region, and the critical value is right there. The area of that red region is 0.05. If it was 0.01, I would do that, and that would be our critical value, but it's 0.05, all right. So this is here again. How many? 2. All right. All right, so now we're going to do, well, the rejection region is going to be Z is greater than 1.64. Where's that? Z? Right here, right? Because it's right-tailed. Okay. Right now, the standardized test statistic, use technology. Great. All right, I'm going to show you how to do that. So let's see if I got StatCrunch up here again. We are going to, now pay attention to this because all these problems here, you're going to use the same method. All right, so go stat. We know this is Z because sigma is known, right? And that's a normal distribution, sampling distribution. So stat, it's a Z stats is the one you want, one sample with summary. If they give you a bunch of data points, it's with data, but most of these are summarized, right? In other words, the sample mean is already calculated. So here's with summary. All right, let's fill these in. The sample mean, a random sample of 30, well, the sample size is 30. Put that in here, 30. Breakfast has a mean sodium content of 914. Now, where's that going? That is the mean of the sample, so that's the sample mean, 914. All right. Assume the population standard deviation is 23. That's right here. All right, now let's finish this last part here. Okay, so our HA is, the mean is greater than 922. So we're going to put 922 here, and our alternative hypothesis is greater than. Now this just shows the equality. I think StatCrunch is trying to say, look, make sure your equality is here. This is going to be the assumption that we make. But your test is determined by HA, and that's a right-tailed test, right? And the last thing was alpha is equal to 0.05. We're going to do this here, and that's 0.05. So let's do it. We don't need the plots or anything else. Okay, compute. All right, so look, this is what this gives us. Here's the p-value. Man, it's a monster. Our critical value is here. And this is our test statistic. All right, the test statistic is the z-stat. All right, so let's finish this off. Identify the standardized, that's why it's z, test statistic is this thing. All right, round to 2 decimal places. That's a 1. All right, that's the test statistic. And then decide whether to reject or fail to reject the null. All right, well, there's 2 different ways I can do that. So that's good we did this problem. We can look at the 2 different ways. First of all, is Z, the rejection region, is Z greater than 1.64? The test statistic is way less than that. It's on the other side. So we can't, that's not in the rejection region. We can't reject it. The other way we could do that would be to look at the p-value. Our p-value is 0.97. Is that less than alpha? And alpha was 0.05. This is way more than alpha, so we fail to reject. All right, so this is where, let's get rid of the StatCrunch. This is where you get confused. Fail to reject. And when you fail to reject something, you never have a chance to say much about anything. You can't support anything. You cannot support anything. So let's look for the fail to reject. So it's going to be C or B. And I'm liking this, says not sufficient evidence to reject the claim. That's exactly what we can't. We don't have, that's it. Let's see what this one says. Okay, fail to reject. And then it says there is sufficient. So that cannot be right. When you fail to reject H0, you can never make a statement about anything. All right, so this is the right answer. All right. And that's it. All right, so I hope, let's see here. Okay. Oh, I hope that made sense. There's only, a handful of problems here, but work through that. I think just relax, try to learn one thing at a time. Watch the video over and over, like the last one, and just step through it. It's not difficult. It really is not difficult. So anyway, good luck with this, and I'll see you next week.